Hi, my name is Jason Collins, and this video is about the principal-agent problem. The allocation of decision rights in a firm creates a problem, as the interests of the owners and employees are not always aligned. This is known as the principal-agent problem. Principal-agent problems are typically modelled as a game between two players, the principal and the agent, who face a conflict of interest. In the case of an employer and employee, the employer is the principal and the employee the agent. The misalignment of interests creates a challenge in designing incentives to align those interests. In this video, I examine two classes of principal-agent problem. The first is where the agent's action is observable by the principal. Consider a production line, where the employee has a discrete task to complete. The employer can observe exactly how hard they are working via the number of items they produce. I will show that incentive conflicts do not cause problems when effort is observable, enabling a contract to be developed. The employer can simply specify the appropriate level of effort for which a bonus is payable. However, outside of idealized problems, an agent's effort is not usually costlessly observable by the firm. They can't simply contract to deliver a set amount of effort. Further, output may not reflect effort. There are likely other effects on output besides the agent's effort. In addition, other proxies for effort might be difficult to measure. Consider an employee whose role is risk management on the production line. Their activities might include checking the quality of the products, developing safety policies, liaising with management, and dealing with unexpected events. The firm can't observe the effort that goes into these tasks. Therefore, a second class of principal-agent problem involves hidden actions, where the conflict between the principal and the agent is over an action the agent may take, and this action cannot be detailed in a complete contract. The agent knows what action is taken, but the principal doesn't. For our employer-employee problem, the hidden action is the employee's effort. There is a problem because the employer would like the employee to work hard, whereas the employee would prefer to take it easy. To illustrate the principal-agent problem, I will now illustrate this challenge with observable and unobservable effort. First is the case of observable effort. The owner of Acme Corporation wants their employees to put in higher effort and work diligently. However, their employee Ian, while liking to be paid, doesn't like to put in effort. As Ian's income goes up, he is happier, but he is also happier the more he can lounge around in the office and cruise Facebook. Ian won't get out of bed and turn up to work for less than $1,000 per week. That is what we call his reservation wage. He then needs to be paid for his efforts in the office. He has a mentally taxing job, so each hour of effort is harder than the last. As a result, he will demand a salary of at least $1,000 plus a compensating amount for whatever level of effort he provides. The firm benefits from Ian's effort, receiving around $100 for every hour he applies himself. If the firm could tell whether Ian was working or not, they could just agree on a level of effort, pay him an agreed sum for it, and then monitor to make sure he delivers. What is that sum? The firm will want to pay Ian the sum that maximizes its profit. Ian wants to set his level of effort to balance his desire for income and the increasing cost of effort. As the firm receives $100 for every hour he works, they will pay Ian up to the point where he demands more than $100 for each additional hour. In classical economic terms, the marginal benefit to the firm of each hour that Ian works is $100. Their profit will be maximized when that marginal benefit is equal to the marginal cost of inducing an additional hour of effort from Ian. The firm could pay him more to get even more effort and output, but the cost of inducing this effort would exceed the benefit they receive. Here is the problem illustrated graphically. On the horizontal axis is the amount of effort expended by Ian. The costs and benefits of Ian's efforts are on the vertical axis. The dashed blue line represents the increasing benefit from each hour of effort. Each additional hour of effort delivers $100 extra benefit to the firm. The curved black line represents the cost of effort to Ian. Each additional hour of effort is harder to deliver than the last, so Ian's cost is increasing in the amount of effort. From the firm's perspective, for any level of effort, they gain the benefit of $100 per hour expended. They have to pay the cost of Ian expending the effort. As a profit-maximising firm, they will achieve their objective when the gap between cost and benefit is maximised. Visually, you can see this point on the chart where the gap between the two lines is largest. What you might notice is that, at this point, the two lines are parallel to each other. They have the same slope. This indicates that the marginal benefit of the effort, the amount the firm gets for one additional unit of effort at this point, equals the marginal cost of the effort, the amount that the employee demands for expending one additional unit of effort. If Ian were paid for another hour of effort over the optimal level, he would demand more than $100, reducing the firm's profit, as the firm receives only $100 for that additional hour of effort. Conversely, the firm's profit would decline if Ian were paid for 1 hour less effort. At that point, Ian demands less than $100 per hour for each unit of effort, meaning the firm could gain by paying for the hour and receiving the $100 output. I will now turn to the case of unobservable effort. Erica is a risk-neutral employee of Acme Corporation. If the firm could observe Erica's effort, the firm could simply develop a contract under which Erica is paid for a set level of effort. However, Erica's effort is unobservable in that the firm cannot, at any point, see how much effort she is putting in. Erica's output increases with her effort. This might suggest the firm could simply contract for a set amount of output. However, for this example, Erica's output is subject to other random effects outside her control. Therefore, paying Erica a fixed salary to deliver a set level of effort or output is problematic. She could blame the low output on bad luck. An alternative is for the firm to pay Erica a fixed sum plus a share of her output. This is feasible if the random effects and Erica's effort are independent. As long as the output and associated compensation increase with every unit of Erica's effort, she will not need to consider the effects on output that are out of her control. Erica will want to be compensated for her effort. She will set her effort level such that her expected compensation minus the cost of the effort is maximised. This is at the level of effort where the marginal benefit of increased compensation equals the marginal cost of additional effort. Here is the scenario illustrated graphically. On the horizontal axis is the amount of effort expended by Erica. The costs and benefits of Erica's effort are on the vertical axis. The dashed blue line represents Erica's compensation, which comprises a fixed sum payment plus the increasing wage from her share of the output. Suppose the firm gains $100 of output from each unit of unobserved effort and is willing to pay Erica a 20% share. Therefore, each additional unit of effort delivers Erica $20. The curved black line represents the cost of effort to Erica. Each additional hour of effort is harder to deliver than the last, so Erica's cost is increasing in the amount of effort. Erica maximizes her utility at the point where the gap between her compensation and cost of effort is the greatest. Visually, you can see this point on the chart where the gap between the two lines is largest. At this point, the two lines are parallel to each other. They have the same slope. This indicates that the marginal benefit of Erica's effort, the amount Erica gets for investing one additional unit of effort, equals the marginal cost of the effort, the cost Erica incurs for expending one additional unit of effort. As Erica's effort and the random shocks are independent, the marginal cost and benefit of effort are not affected by the random shocks that otherwise affect her payment. A random effect that reduces output does not change the fact that extra effort increases output, and accordingly, Erica's compensation. Suppose the firm decided to increase the fixed portion of Erica's wage. This has the effect of moving the compensation line in the diagram upwards. Although this increases Erica's income for any specific level of effort, this does not change the incentives for Erica, as the marginal benefit and cost remain equal at the same level of effort. She will apply the same level of effort regardless of the fixed wage change. As a result, the firm's profit would drop. The firm could, alternatively, increase the share of the output it pays to Erica. This increases the slope of the line for compensation. The marginal benefit of an extra unit of effort will now equal the marginal cost at a higher level of effort. Erica's effort increases. Whether the firm is willing to do this depends on the profit maximising level of effort and compensation.